We're going to find the volume of a solid whose base is bounded by the circle x squared plus y squared equals to 2x, and cross sections that are perpendicular to the x-axis are equilateral triangles. So first we're going to sketch the base. We're going to first complete the square. Take x squared, subtract 2x, add y squared, that's equal to 0. Then add 1 to both sides, x squared minus 2x plus 1 plus y squared equals 1. We added 1 because we take minus 2 divided by 2, which is minus 1 squared, that's 1. We can now have complete square right here, which is x minus 1 squared plus y squared equals 1. And this is a circle whose center is at the point 1, 0, and whose radius is 1. Let's graph this circle and then draw a representative cross section. So this is what the circle looks like. Its center is at the point 1, 0, and its radius is 1. So it'll go over here to 2, and that's what this circle looks like. Now, cross section perpendicular to the x-axis. What does that mean? Pick an arbitrary x. Cross section means that when we cut this perpendicular to the x-axis, the cross section is going to be an equilateral triangle. One of its sides is on the base. So here is what the cross section looks like. And this is an equilateral triangle. If the area of this triangle is a of x, then the volume of our solid will be integral from 0 to 2 a of x dx. So this problem comes down to expressing the area of this equilateral triangle as a function of x. So recall, when we have an equilateral triangle, and let's say each side has the same length, it's s, the area of this triangle as a function of s is square root of 3 divided by 4 times s squared. So all we have to do is express the length of a side of this triangle as a function of x. So here is our s. As you can see, it can be computed in one of two different ways. First, we note that if we solve for y squared is equal to 2x minus x squared. So y will be plus or minus square root of 2x minus x squared. The upper semicircle here, that's y equal to square root of 2x minus x squared. And the lower semicircle, y is equal to minus square root of 2x minus x squared. So s could be expressed either as twice the distance from the x-axis to the upper semicircle, so that's twice square root of 2x minus x squared, or it can be expressed as upper semicircle, that is a square root of 2x minus x squared minus the lower semicircle, which is minus square root of 2x minus x squared, and of course that also gives us twice square root of 2x minus x squared. And that's the length of a side as a function of x. So the volume will be the integral from 0 to 2 square root of 3 divided by 4 times the length of the side squared. Squaring s gives us 4 times 2x minus x squared. And so the 4's cancel. We can put square root of 3 in front of the integral. So this is square root of 3 integral from 0 to 2, 2x minus x squared. That's an easy integral to solve. The integral of 2x is x squared minus 1/3 x cubed, evaluated from 0 to 2. So we have Square root of 3 times 4 minus 8 thirds. 4 is 12 thirds. 12 thirds minus 8 thirds is 4 thirds. So the final answer is 4 times the square root of 3 divided by 3 units cubed, because that's the volume. Volume is measured in units